compulsory go through this networking, compulsory read it because it's a major portion. So why I'm telling faster, why? Because if you feel very fast, then please tell me, I will go slow. Okay, because we need a overview plus some troubleshooting related to the networking. Okay, so today and tomorrow we'll finish this networking part, because networking part is a very big one, and troubleshooting is also very important. The requirements to form a network, of course, we discussed about what is a network. Connection of two or more devices, right? What is a network? Connection of two or more devices. What is networking? Is communication between two or more devices. Internetwork means connection of two or more networks. Internetworking means communication between two or more networks, right? To form a network, like we can form a network. Either it is any topology we use, like physically we have to connect the devices. The way you connect the devices, based on that, it is a different physical topologies are there: bus topology, ring topology, star topology, mesh topology. Okay, and we are using star topologies. Okay, so for example, you have a PC or a server or a devices. So to communicate, to connect in the network, to connect in a network, so we need a interface card for a device. For example, you take a mobile phone, you connect a mobile phone to Wi-Fi. So in your mobile phone, there is a Wi-Fi chip is there. Inside a Wi-Fi chip is there. So using that one, we can able to connect it to Wi-Fi. Or you are getting, sir, you can say like I'm not connected to Wi-Fi, but still I'm getting internet. Of course, you have a 4G chipset. Side 4G chip is there. So 4G internal antenna is there. So you receive a signal from your tower to connect data through tower. So again, you require a 4G internet related chip should be enabled. Like data is enabled, then we can able to connect 4G data. Okay, so that is the interface for that particular device, particular way. Okay, you have a laptop, so then you can able to connect your Wi-Fi. You have a PC, then you are connecting with a wire. So what are the media you are using to connect? We need a interface. Okay, and in generally, so we are always stuck in the basics from starting. So we have a computers or a servers. We connect usually with the wires, right? So then we use a kind of NICs there. What is NIC? Network interface card. What is NIC? Network interface card. In the olden days, on motherboard, on computer motherboard, we don't have direct NICs. We have to insert NIC cards like this. So this is the cable connecting point. This unit will go inside your computer, so connected to your motherboard. This is the part. Nowadays, like how to search, like a laptop. Like this. So if you check the laptop also, we have this connection, right? So we will connect a wire to this ports, right? This is the socket. We call it as a RJ45. RJ45 port or RJ45 socket. So like this will connect. Okay. So see, this is how we are connecting. Okay, this is a laptop, so you can go to desktop also. So this is a RJ45 plug. This is the cable. This is NIC. This is a small hub. A switch. It is switch. It is written switch. It is a switched connection. So it is a our PC backside. We have a RJ45 connector. In the olden days, we don't have these connectors. So what they will do is they will insert these NIC cards. NIC cards. So then we can able to connect this connection. So they will insert. This is having 4 NICs directly. Okay. Or maybe you can have a one single NIC cards also there like this. So they will insert these cards into the computer directly. So internally, so then we can able to get connected with the wires. So what is this? This is a NIC, network interface card, also called as LAN card or Ethernet card. Nowadays, we are also using a Wi-Fi cards, right? So built-in laptops or mobile phones, and also USB Wi-Fi connectivity is also came, right? So whatsoever it is a interface card, interface to the network. So to connect to the network, we need a interface card or a interface, network interface. So we call simply as a NIC, also called as LAN card or a Ethernet card. So we see this is Ethernet card. These Ethernet cards are mainly 3 types: Ethernet, fast Ethernet, and Gigabit Ethernet. Ethernet, fast Ethernet, Gigabit Ethernet. In olden days, we have only Ethernet. That speed of connectivity is 10 Mbps. Okay. Then this Ethernet, further next version of Ethernet is fast Ethernet. So the connectivity speed is 100 Mbps. Gigabit Ethernet. So it is much faster than fast Ethernet. That is 1000 Mbps or 1 Gbps. Guys, here it is. The B means small b we are using. Small b represent bit. Bit means either 0 or 1. Okay, either 0 or 1. Capital B represent byte. So small b represent bit. Bit means in a binary 0 or 1. Byte means capital B. Capital B, byte, B-Y-T-E, byte. It meaning is 8 bits. It is a size like a, foot, centimeter, millimeter. Similarly, okay, it is a data size. It is a bit means it's a only one single, either 0 or 1 only. But if you put a 8 bits, it's a single byte. Okay, a byte means 8 bits. Kilobyte means 1024 bytes. Megabyte means 1024. Kilo means here 1024. Normally, you go to grams. Gram, kilogram. What is kilogram? 1000 grams is kilogram. 1000 meters is kilometer. But in our computer in a binary, so we are using 1024 as a kilo. Why 1024? It is because of binary system 2 to the power of 10. 2 to the power of 10 is kilo. Okay, 2 to the power of 10 is 1 kilo. Okay, so then okay, like that. Megabyte. Megabyte means 1024 into 1024 bytes. 1024 into 1024 bytes or 1024 kilo. Next, always it is go through like 1024 difference is there, means multiplication is there. Gigabyte, terabyte, petabyte, zettabyte, terabyte, so many other bytes also there. You can do it. So 1024 into, okay. So this is a table for a, this is a table for a decimal, binary, hexadecimal and octal. I think so everybody knows. If you don't know, also I will explain it. No problem for me. Okay. So PS, bits per second. BPS, bits per second, megabits per second, gigabits per second. So this is about a Ethernet. Next, every NIC. So you have a NIC to connect, right? So this every NIC having a unique 48-bit address is there. Okay, so 48-bit address on the every Ethernet card or NIC card. That we call it as a MAC address. That we call it as a MAC address. MAC means media access control. MAC means media access control. This MAC address is also called as a physical address or hardware address. So this MAC address is given by manufacturer of NIC. Manufacturer of NIC. So you have a NIC. So you have a NIC. This NIC is manufactured by someone. So you can see it's a D-Link NIC. It means this interface card manufactured by D-Link. Okay. Qualcomm. My NIC is a Qualcomm NIC. This is some LR link. Links is TP-Link. TP-Link. Okay. Different companies are there. Realtek. Realtek. It is showing. Realtek. Yeah, this is okay. So this is a Realtek manufactured by Realtek. This is a Realtek symbol. So Realtek is manufactures mainly like NICs and audio chips. Audio chipsets also manufacturing of Realtek is there. Okay, so the manufacturer, whoever it is a manufacturer by someone, right? So either a Realtek or Qualcomm or maybe a MediaTek, okay, or a D-Link, TP-Link. These are different manufacturers of a NIC. What these manufacturers will do it, when they manufacture a LAN card or Ethernet card, what they will do it, they'll put a MAC address on it. Means on this chip only, directly they put a MAC address. So this MAC address cannot be changed. We cannot change the MAC address. So what is a MAC address? Media access control, also called as a physical address or hardware address, unique address it is. So it contains a unique address. It means that MAC address is not repeated again, just like your thumbprint. One PC MAC address is not exist in the world. In the entire world, the MAC address is not existing. Okay, the MAC address is not existing in entire world. How it is possible? Because of it is given by manufacturer. The manufacturer ID, the MAC address contains the manufacturer ID and series. Two parts of MAC address it is. Okay, so MAC address cannot be changed. Okay, IP address can be changed, but MAC address we cannot change. MAC spoofing is possible. Only we do MAC spoofing for attacking or securing network. For attacking the network or securing the network, we do MAC spoofing. MAC spoofing means duplicating MAC address. Using some softwares or scripts, we can duplicate our MAC address. Means original MAC address is not changing, but while you are communicating, we'll communicate with a different MAC address. Okay, so for both attacks, for hacking in the LAN communication attacks through LAN, or to defend our network, so to manipulate ourselves in the LAN, also we can use MAC spoofing. MAC is only valid, your MAC address is only valid in your LAN communication. And of course, there is certain rumors are there, like if anybody knows your MAC address, any hacker knows your MAC address through internet, so they can hack you. No, guys, your MAC address is not going after your router. So once you are cross your router, your MAC address is no longer valid. Your router MAC address is danger, but not your MAC address. A mobile phone direct internet access, that is a different point. So that is again different. In generally, so MAC address is up to LAN only. We cannot communicate with the MAC address. Like you want to send a packet, like you are pinging from PC1 to server A using MAC address, ping and server A MAC address. No, it won't work. All communications by IP address only. We cannot communicate with the MAC address. MAC binding is also possible. MAC binding means list of MAC addresses given in your Wi-Fi router. So whenever a client is trying to connect your Wi-Fi, it will check the client MAC address against to the list. Okay, if it is there, it is allow the connection. If MAC address is not mentioned in the list, it don't give the connection. Very simply say, MAC binding is allow or deny list of MAC addresses whenever the client is trying to connect it. So if it is allowed, then it will allow the connection. It is not allowed, then it is deny the connection. That is a MAC binding. For security purpose, we do MAC bindings in a Wi-Fi routers, Wi-Fi network. In generally, wide network also we can able to do it. For example, you have a Wi-Fi router, and like you told to one person, like I have done. Okay, I told to my Wi-Fi password to my owners and as well as one of the neighbor. So one day I have checked my router, something, my internet is slow. Then I check my router. I open my router portal from my laptop. So it is showing there is several connections are there. And I calculate which is my laptop connection, my desktop connection, my mobile, my tablet and all. I've seen there is a 5-6 connections must be there. Other than 5, there is a extra 3-4 connections are there. Then I realize so someone is trying to take my connection. So I disable them immediately. So they cannot able to get connected. Okay. So allow and deny list we can able to create in your Wi-Fi router. So then only we can able to connect it. That is a MAC binding. Okay, guys. So what is a MAC address? MAC address is a physical address. It is a 48-bit in size. Okay, it represented in a 12 hexadecimal. And this is the MAC address. This is how MAC addresses look like. It is in the hexadecimal format. Guys, hexadecimal formats always having a 0 to F type. Okay, the start with a 0 and with F in a single digit manner. Like in a decimal, 0 start, 9 is last. After 9, 10 is came. Again 10 means it's a 1 0, means 2-digit number. But up to 9 it is a single digit number. Same goes for a hexadecimal. Up to 0 to F it is a single digit number only. 0 to 9 and for 10 it is like a B, C, D, E, F and 1 0. 1 0 means it's not a 10. It is 16. In decimal it is a 16. In a hexadecimal it is 1 0. 1 A is there. For example, 1 A is there. 1 A means it's we have to calculate in a binary and a decimal again. Okay, so it is around maybe a 25-30 kind of stuff. Okay, so A means 10. 1 A means not 110, not something like 20 kind of stuff. It is different. So 10 means 16, 11 means 17. Like that you have to calculate. Okay. So that is hexadecimal numbers having both zeros 0 to 9 numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and A, B, C, D, E, F. Maximum F only. Okay, not G, H, H. That kind of stuff is not in the hexadecimal number. Okay. So this is the MAC address. How to check the MAC address? How to check the MAC address also important, right? So we already know how to check the IP address. In the same place only we check the MAC address. So either you go to ncpa.cpl. Okay, so first of all, otherwise you can go to control panel, network and sharing center, change adapter settings. You will get to network and network connections, or ncpa.cpl also will give you that. So open your adapter, go to details, see the physical address. So this is your MAC address. Description means your manufacturer of NIC and the model number, and it is MAC address. Okay. We can see any NIC. It is. This is the MAC address. It's at 12 hexadecimals. Also, you can check the MAC address using command prompt like a CMD. Use getMAC. GetMAC is a command to check the MAC address. Of course, you don't understand which device it is exactly, because I have a lot of NICs are showing in my control panel, right? So that's why it is confusing. If you have only one NIC, then automatically we can understand that is your MAC address. But here it is, little confusion is there because I have a multiple devices. Also you can get a MAC address by using ipconfig/all. ipconfig space/all. So here it is. This is my Wi-Fi and this is my physical address. This is my VMNet2. This is my physical address. This is VMNet8. This is my physical address. This is my VMNet1. So that NIC is my address. Either it is a virtual NIC or a physical NIC, either it is wide NIC or Wi-Fi NIC. It contains a MAC address. Okay. So that is the point here, guys. Of course, you know how to check the IP address, ipconfig and ipconfig all also showing an IP address. If it is showing DHCP enabled, means you got IP address from DHCP server. If it is showing enabled no, means the IP address is configured manually. Okay. If you got IP address from DHCP server, it is also shows DHCP server address and leaves obtained, leaves expiry also mainly, guys. And on NIC, so we have seen NICs, right? On NIC, so usually like a wide type of NICs having two LEDs. One LED represent activity, another LED is link. Okay, so activity LED is shows dark, means link is down, means you connect a wire but there is a wire problem or maybe a switch problem. Okay, so obviously you're connected but it is link is down. There's a possible things are there. One is there may be a wire problem, or maybe your PC NIC drivers are not installed, or you disabled NIC in your PC. Either you disable your NIC or drivers are not installed, so NIC's drivers are not there. Okay, or maybe a cable problem, or maybe a switch connectivity problem. Okay, so in these cases we will see activity LED is down. Okay. If it is blinking, then there is a connection. Okay. It is active. It is active. If it is showing a stable, yellow stable, again it is inactive, means there is a problem. It should be blink, either it is green color or yellow color, it should be blink. Keep blinking. Next, link LED. Link LED is dark, means its link LED is not blinking. Your connection is 10 Mbps connection. It turn into the green, it is 100 Mbps. Amber means it is 1000 Mbps. Blue means it is 10,000 Mbps. That is a different point. Okay. Mostly it is yellow or yellow green kind of stuff. You want to see the blinking also, you can see. Check the LED status like this. Okay, so this is showing yellow and it is green. Like this. So it is activity speed. So live is also there. Let's see. LEDs are blinking. By blinking, we can understand the connectivity. Okay. So compulsory check how it is. The blinking meaning is okay. Yellow blinking, green blinking means activity. So green, amber kind of stuff. It is also shows green connectivity LEDs. Anything is there that up to NIC part. Okay, this is up to NIC. Guys, understand about NIC: network interface card, LAN card, Ethernet card, fast Ethernet card, Gigabit Ethernet card, and MAC address, and how to check the MAC address. Understand up to now?
Yes, sir.
Very
Yes, sir.
Yes, sir.
good. Okay, so I think I told very slowly. So compulsory, each point is very important, guys. Okay, each point is very important. I think I forward some questions also. We can check that MAC address is how important. Next one is we are going for a cables. Before going to cables, I want to tell some words here. EMI means electromagnetic interference. Crosstalk. Crosstalk means mixture of two or more signals. Okay, mixture of two or more signal. That is called a crosstalk. Attenuation means, so how much, like attenuation means you transmit a data, you transmit a certain power in certain place, like a certain distance, the power will be reduced, the signal strength will be reduced, or opposing the signals. Attenuation means opposing the signal. Okay, baseband, broadband, laser lines. So you can try what is the baseband means. I'm speaking, right? My speaking capacity is like my frequency, the voice frequency of human voice frequency is 20 to 20 kilohertz. Our hearing capacity is also in the frequency 20 to 20 kilohertz. Okay. So for example, you are using TV remote. So it uses a base frequency. Okay. So like that. So base band means the original data transmission speed. Broadband means we will manipulate, means we add this signal to the high frequency signal, so then we can transmit the data for a long distance. So that is a broadband signal. 10 base T. For example, you take 10 base T. It's a okay, sorry. Okay, what is a 10 base T? It's a 10 Mbps over the twisted pair cable like that. 10 bit by 10 Mbps. 100 base T. 100 base T. That is also a standard base. 100 Mbps or a twisted pair cable. Okay. Leisure lines. The speed are decided by leisure lines also there. Like a T1, E1 lines. Okay, so T1, E1, E1 is there here. The T1, E1 are a private or a leisure line services. It is dedicated service because the lines are dedicated point-to-point service for a single user. They attract to attribute different generic internet links. Okay. So what is these leisure lines? It is a dedicated lines between two or more organizations or two or more places. Like in Hyderabad, we have a 70s. In New Jersey also we have a 70s. So I use a dedicated lines for a direct communication from here to there. There is a standards like a T1, E1, T2, T3, T4, T5, like that. Okay. So each line has a certain speed. T1 speed is there, E1 speed is there. Okay. This is E1 European variant. It is defined by European Conference of Postal and Communication Administration. Okay, provided for a speed link. Like E1 speed is 2.048 megabits per second speed. Okay. You can go to this also. This is again E1. So then T1 type of communication, it is not showing here, but 1.548. Okay, sorry, 1.544 megabits per second. Okay, it is also a connection types. Okay, I'm telling not to confuse you guys, just I am telling you so what it is. Okay, but we will go to the cables directly. First type of cable is they use coaxial cable. Okay, I'm not giving more details about a coaxial cable because of in our network we are not using coaxial cables nowadays. Of course, some countries like US based countries still using coaxial cables because they will provide both TV communication and internet communication through coaxial cables. Where already I told, I think your batch or another batch in India, we don't do that one. Cable TV is cable TV, or dish TV is dish TV. Internet is internet. Internet in our India either by through telephone cables, like a BSNL telephone cables, or a Airtel telephone cables. Airtel also using telephone cable. BSNL using telephone cable type connectivity. Okay. Nowadays we are using direct fiber optical cables like a ACT, Airtel, BSNL in a city areas, BSNL, okay, ACT, fiber optical cables. Okay. So fiber nets we are using nowadays for a internet purpose. So olden days for certain areas coaxial cable. Of course, in those time also there is a separate NICs. What are the NIC I showed? Not that NIC, different NIC because the cable is different here. Okay. So it is a coaxial cable, guys. So it contains a single center conductor is there. No, that is a single copper cable is there. In centrally, there is a single copper cable which is covered with a plastic material, and again that is covered with a a shield. Mesh shield is there. What is the use of this mesh type of shielding? It is also copper material only. What is the use of this mesh shield? To protect your signal from electromagnetic interference. What is this electromagnetic interference, guys? Somewhere there is a tower, mobile tower. We are getting signal. How? Electromagnetic interference. Somewhere there is a tower, but for your mobile you are getting signal electromagnetic interference. The frequency matches, it will. You have a Wi-Fi, you are getting connection to Wi-Fi, radio signal, electromagnetic interference. So you cannot able to see this electromagnetic interference. Okay, if you go any big transmission lines, power transmission lines, electrical transmission lines, you may see in that that is electrical interference is there. Okay, induction is there. Magnetic and electrical both are there in a EMI. So in the existing, so we can't see, but it is there is a electromagnetic and signals are there in the space, means in our regular place. Okay, so what happened? These electromagnetic interference effect on your main signal. It causes crosstalk, means it will create a disturbance or damages your signal, or mixing the your signal part is there. So it will, your data will maybe lost, or maybe other data will be added, kind of stuff. To protect the cable from electromagnetic interference, we use this mesh shield. And there is a different type of connections are there, like a BMC connection, British Naval connection, ENC connection, T-type connection, that type connection. So many type of connections are there. But our importance is go to twisted pair. Twisted pair. What is this twisted pair? Of course, these are wires. In the twisted pair cable, we have 8 wires or 4 pairs. Each pair of cable twist each other. Why twist? Why twist? As per the transmission lines, okay, as per a theory of transmission lines, there is a attenuation. Attenuation means opposing the signal. Okay, so this attenuation will decrease if number of twist are increases. Number of twist are increases, the attenuation decreases. So that's why twist are there. So that's why it is called as a twisted pair cable. In this one, 2 type of twisted pair cable is there. Unshielded twisted pair cable, shielded twisted pair cable. Unshielded twisted pair cable does not contain shielding. That's it. 8 wires are there. It covered with a one plastic cover. Okay, a plastic outer cover is there. So it is covered like that. Unshielded twisted pair cable having a this mesh, again copper mesh is on the wires and it is covered with a plastic cover. What is the use of this shielding? First of all, it protect your signals, your transmission from electromagnetic interference. For a electromagnetic interference, again I told like a electromagnetic interface cause crosstalk, mixture of signals. Okay, and also it will strengthen the cable. It strengthen the cable means sometimes you have to run the cable over the false ceilings, in edges, under the tables. You know what happened? Sometimes a small pressure will apply on the cable. It damages internal wires. Because of this shielding, it give a strength. So then the pressure won't go much on this internal wires, and also it protects from the racks also possible. Again, I'm telling guys, this is contains of four wires, not four wires, four pairs. Each pair is twist each other. Totally 8 wires are there. 4 wires are colored, purely colored with a blue, orange, green, brown. And another four wires. 4 wires are blue, green, orange, brown. Other 4 wires we call it as a white cables with a color on it. Okay, another 4 cables are white cables, but there is each cable having a color on it. So that's why they call it as a white blue, white green, white orange, white brown. So I've written reversely. Okay, so you can write in another manner also. So because of it's actually white wire having a color line is there on it. Okay, so white, blue, white, green, white, orange, white, brown are there. Totally 8 wires. To connect this cable, so we are using these cables. So to connect these cables, we use a RJ45 sockets, plugs, kind of stuff. Okay, what is RJ45? Registered jack. What is RJ45? Registered jack. 45 is a standard number. RJ11 is telephone cable. RJ45 is network cable. Okay, RJ45. The plugs you can see here, it is the connections RJ45. In a NIC also I shown this is RJ45 socket, RJ45 plug. Different categories of cables are there, guys. Cat1, Cat2, Cat3, Cat4, Cat5, Cat5e, Cat6 cables are there. In generally, we are using currently Cat6 cables only. Cat6, this is information about a speed that is may not be accurate. Okay, so do not think this is the accurate part. Okay, so you have to refer the categories and speed usage. You have to refer from either CompTIA N plus textbooks or Cisco networking related textbook, CCNA or a networking essentials textbook to get the original information. Because in internet there is a lot of manipulation is also there. Just to show that there is a categories of network, each category having a different speed limits. Okay, the speed limits because of the twisted pair. Already I told number of twist increases, attenuation decreases. Attenuation means opposing the signal strength. So the opposition is reduced, speed increases. Okay, so that is your category. Next, different tools we are using to create a cables, to connect the cables or testing the cables kind of stuff. This is the cable tester. So it is look like, okay, and there is a crimping tool. For example, you have a cable and a connector, you want to connect that plug to the cable. We use this crimping tool. Once you've done a crimping on both the sides of the cable, you have to test it, right? So we can use the testing tool. This is called a patch cable. Patch cable and cable not a different, guys. Patch cable means it's simply a cable which is having a plugs both the sides. It's a simple patch cable. So we can connect your computer to your switch or the nearby the box is there na LAN connection box. You want to connect it, so then we can use a cable. That cable we call it as a patch cable. For example, once you are joined into the company in your organization, so someone asks, give me that patch cable. So don't put a blank face there. Okay, don't put a blank face. What is a patch cable? Patch cable means it's a patch cable. Okay. So I said there is a color coding on the cables, right? Why we need a color coding? So to proper connecting. Okay, So depends upon which device to which device you are connecting. You have to prepare the cable as per that one. These are the cable types, like a straight through cable, crossover cable, rollover cable. Straight through cable, use it to connect your PC to a switch to router. Straight through cables are used. Crossover cable means it's a different combination. So different color combination it is. Internal wire combination it is crossover cable. I'm not going in that depth. Okay. So crossover cable are used to connect a PC to PC, switch to switch, router to router, router to PC, crossover cable we are using. Another type is rollover cable. In generally, we don't use rollover cable in a communication. Rollover cables are only used for configuring routers, switches, like a Cisco company providing different type of routers. So like we can able to configure that router. Some switches we can configure by creating VLANs and all, we can create it. Again, a router also routing information we can configure it. Okay, to connect your PC to the router or a switch, to configuration purpose, for console connection purpose, we use a rollover cable. Okay. So that much not required, but it is understand twisted pair cable. Why twisted pair cable? It is a each pair of cable is twist each other. There's a two types: unshielded twisted pair cable, shielded twisted pair cable. Two type of cables are there. Unshielded twisted pair cable, there is a shielding which is protect you from electromagnetic interference and strengthen the cable also possible. Okay, so we use a RJ45 connectors to connect the cables, and these cables are having generally 8 wires, which is color coded. Different categories of cable depends upon the category we are getting speed. Generally, we are using Cat5e or Cat6 cables. Tools we are using in the cable technology. Okay, so this is one part. Okay, just breathe 1 minute. So then we'll go to fiber optical cables. What happened? I don't know. I'm hearing sound, but from where I'm not. Yeah, we'll continue, guys. That is fiber optical cables. Fiber optical cables are made up of glass. It is made up of glass. And here we are not using electrical signal. In a coaxial cable, we are using copper. In coaxial cable, we are using copper. In a UTP STP cables, also we are using copper. Copper is a metal and it is very costly. Okay, it is very costly. Okay, and copper cables don't give high-speed data transmission. Copper cables don't give more high-speed data transmission, and very long distance communication also don't support. And that to this UTP STP cables support up to 100 meters only. It irrespective of what category it is, how many twists are there. So it support only maximum 100 meters only. Okay, so coaxial and copper cables always having a fear of electromagnetic interference because it's a metal. So metal attracts electromagnetic interference generally. Electrical metal passes electricity, right? Okay, so that's the thing. So made up of glass. So fiber optical cables are optical fiber cables. The wire that we are using, it is made up of glass. Glass is actually made from limestone. Limestone, and generally we are using limestones, right? Like a sand, silicon material, limestone. Okay, it is a cheaper in generally. It is not a metal. It is non-metal. So no electrical or magnetic interference. So no EMI. We use a light wave, not electrical wave. Here it is. We should use light wave to send a signal. Light wave is basically a photonic communication. So the length of communication means the traveling to the longer distance is possible. High speed data transmission is possible. Okay. So very long distance communication we can do it. Very high speed data transmission we can do it. You can ask me a question, that is, so if a fiber optical cable is providing long distance high speed data transmission, and why we are using this copper cables? And of course, as I said, copper is costly and glass is cheaper. Then why can't you use glass? Problem with these cables for a regular communication, means basic LAN communication kind of stuff, there is a one problem. So here it is. It is a cheaper as well as a costly. So how cost effective is there? Look at here, guys. To create a cable like a dispatch cable, okay, you want to make this patch cable or you want to buy this patch cable, it is cost is normally very less. Or you have got some problem with your cable connectivity, then you remove the connectivity and you can connect it like this. You can use these crimping tools, testers, and RJ45 connectors are a cheaper. But whereas these fiber optical cables, the cable connectors and the tools we are using, we have to test. This is special equipment is there, separate special equipment is there. So you have to get trying to use this kind of cables. And if you are want to use a fiber optical cable, your laptop or a desktop should be inserted with a this kind of NICs. This is also NIC. Okay, this is also one kind of NIC. It is called a host bus adapter, which is used to connect fiber optical cables. And your switch also must be fiber optical switch. So the cost is increasing by one. Of course, sometimes you feel it is a costly, sometimes it is not costly. How? For example, I have a servers, data storage devices. Okay, so data access. For example, take a Google. Google per second millions of data is transmitting, right? Millions of data is executing. So they need a fiber optic cables for inside. Like an organization maintaining SAN, means storage area networks. They use a fiber optical cables in a SAN. In SAN, we use a fiber optical cables. Server to server communication, data centers, they use a fiber optical cables. Data centers, they use a fiber optical cables. Why? Because they need a high speed data transmission. We are don't require that much of high speed data. Our internet speed is less than 100 Mbps, right? 50, 100, 150 is also coming. Not more than that till now. Okay. Next, these fiber optical cables are very important to get a internet also. Okay. A lot of people think we are getting internet through satellites. No, guys, we are using internet through satellite is very less. That too only specific organizations only. Until unless Elon Musk gives us a solution, internet through satellite kind of stuff, we may get in a future internet through high-speed data transmission through satellites. But now we are getting internet through cables only. These cables are connected country to country, continent to continent over the seas. You can use a website called as Submarine Cable Maps. You can see how these cables are connected. So India is connected to multiple countries. Like in India, there is some parts. One is Mumbai, and in a Kerala, Tamil Nadu, Chennai, places like we have a connections. In almost like a 95, 98 time, almost like a 98 time only. 98, 98, no, not 98, 2000. I'm in diploma 2000, right? So it's around 2000 time. You may not know, but there is a Reliance, Tata Reliance mobile phones are came. Reliance to Reliance free, Tata to Tata free kind of stuff. Reliance runs CDMA mobile phone without a SIM, okay, and it is some charge is there, 500 rupees charge per month, something is there. It immediately highlighted, immediately they break into the market, so automatically we start trusting Reliance. But after using a 1 month 2 month, they are getting lot of bill. Okay, even that's why when Geo is launched, a lot of people are getting doubt initially. We are taking freely, but maybe they'll put a lot of charge to come out from it. Okay, luckily that is not done. Of course, now charges for every mobile now it is very high. Okay, so the point is, that time only the Reliance company, main mother Reliance company, also got this contract like a fiber optical cables installation for India and other countries also. They got this contract. Okay, fiber optical, they have their own fiber opticals. Okay, so that's why we are getting cheaper. So one of the reason is, almost like a 20 years back only, they got a installation of fiber optic. So BSNL having fiber optical cables under ground and over the seas, and next is Jio only, means Reliance. Okay, so we are getting internet through cables, overseas cables, and also you can type in Google like uh, I will put a OFC uh, under ocean, anything like that you can do it. So go to images, see it is under oceans, it's a cables are there, and of course it is fully protected with a lot of iron casing and big plastic fiber casing. It is why, because of under ocean lot of fishes, whales, sharks, they will try to eat it. Okay, so that's why there's a lot of protection on it. Okay, see, it is how global it is connecting. They use a submarines to install these cables. It is outside of this ocean, so it is the cable from that sea to shore connections. So it is also people having certain jobs. Okay, they will go and check the cables under oceans. Okay, so they will go and check the cable, how cable is there, any damage is occur. Sometimes that huge impact, not a one person, for multiple people also unable to get internet, some internet disturbance is there. So sometimes because of tsunamis, sometimes because of there is a huge change happen under seas. Okay, so that is also will get a problem. Okay, yeah, this is about your cabling, guys. So better to know advantages and disadvantages of using fiber optical cables. Advantage is very long distance communication, very high speed data transmission. Thanks. It is a costly as well as a cheaper as well as a costly. It is made up of glass. Advantage is no electromagnetic interference. We use the light waves to transmit the data. Okay. So this is about a cables, and yeah, one more is there, that is a devices. Okay, different devices we use in the network. So once we finish the devices, we can directly go to OSI layers and IP address class. Okay, and small things are there, that is also we can cover. Okay. So what I'm going to do is, I'm not going to give any break, guys. I need just 15 minutes to explain the overview of the devices. Okay, can I continue?
Yes, sir.
Okay, I will
Sir,
give you small point, just like how I told these things. I will tell like that only. So later you have to study, guys. Compulsory study, because this is a very important. Guys, here it is. We use a different networking devices in the network. Hubs, switches, routers, modems. These four devices are very important devices in using in the network. Okay. Hub. What is this hub? It is a small device. It is as per the OSI layers, it is a layer 1 device. Means it's a physical layer device. Hub is suitable for a LAN communications and small network communications. Hub is a non-intelligent device. So where we use hub, we use a hub in a basically LAN communication only. That too better to suitable for a small networks only. It is non-intelligent device. It does not understand what is MAC address, IP address kind of stuff. It does not understand anything. Hub is considered as a layer 1 device, means physical layer as per the OSI layer. Okay. Next one is repeater. Repeater, sometimes hub act like a repeater, and there is a repeaters also there. Okay. Hub, repeater kind of stuff. Okay. So what is this repeaters? When you are sending a signal for a certain distance, okay, so the signal strength will be reduced after certain distance, like 100 meters is a maximum cable length. So you have to send a signal for a further. So what we will use the repeaters kind of stuff. Sometimes you can use hubs also, but whether it is hub or a repeater, it repeats the signal. So you take the signal, it repeats the signal. You don't boost the signal, okay? It is repeat the signal. So then it will go for another 100 meters. Okay. So again, hub actually it is a broadcast domain. So hub, how it is works. For example, hub is connected to a multiple devices like this. Okay. So there is a hub and PCs are connected to the hub. For example, A want to send a packet to C. Here it is I have written, A want to send a packet to C. So A send a packet, then it is hub is taken the packet has to be sent to C, right? So what hub is doing? Hub is simply a wiring, not a proper circuit also. It is a simply back wiring only. Okay. What happened? A send a packet to C, but that packet is goes for a B, C, D, E, F, G, H. How many pieces are there are connected? So those many all pieces will get a packet. So it is called a broadcast. So you are giving something to everyone. So it means a broadcast, right? So hub do broadcasting. So similarly, same time, if other communication is also going, like a B is sending a packet to D, or D is sending a packet to A is sending a packet to E. So what happened? These are because of this broadcast, means A send a packet to C, but same packet is also go for B and D and G and E and F, like that. So same packet is going. So no security. So everyone get a same packet. So what they will do it? So they will check the to address from address. So for example, I got a letter. I check the letter. So what is this letter? It is belongs to me or not? 3-4 days back, maybe not 3-4 days back. Last week it is happened. So one Swiggy guy came and delivering food to me, and I got a doubt. I didn't order any food. My sister also don't didn't tell any food, and luckily he's asking money, like a door delivery. That is that is delivery food charge. He's asking money, and then immediately other doubt I got it. So I checked the door number. So he didn't check the proper door number. So some confusion is happened. So he tried to deliver to me. Okay. He told a name, but names may be confusion also there. So he's trying to deliver to me. So luckily it is like a COD, cash and delivery type. So I understand then, oh, it is not belongs to me. So please check that door number. Then it is different door number. I told, he went there. Okay. So point is, if B is received a packet, if B is received a packet, B drop the packet because it is not belongs to B. Same for a D, also received a packet, it drop the packet. C received a packet, it is belongs to C and it accept the packet. Okay, so this is how Hubs works. It means if A is send a packet to B, that same packet is sent to B, D, C, E, F, G, like that. Okay, those devices are connected, all devices get a packet. Because of Hub is non-intelligent, it does not understand which device, what device it is, like a MAC. By using MAC address or IP address, you don't understand. It is suitable for small network. Why? Because of this broadcasting. This kind of broadcasting causes number of collisions. Packet collisions are there. The collisions lead to data loss. Packet data loss. Okay. So that's why it is suitable for a only small networks. Of course, it is used in a LAN communication. It is a layer 1 device. Yeah, I'm telling big all story. So we'll see. Next is switch. Switch is intelligent device. It can understand MAC address of the devices. Switch is also used for a LAN communication. Switch is also used for a LAN communication. Switch is also used for a LAN communication. As per OS layer, it is a layer 2 device, data link layer. Switch is used for both small and large networks, but LAN networks only. Switch having a number of ports are higher, like a 8 port, 16 port, 24 port, 48 port, okay, 72 port switches also there. So number of ports are higher. So number of devices we can connect it. Okay, in any large network means more than 3-4 PCs you want to connect, better to go for a switch only. Number of collisions are less, and so then number of packet loss also less in the switches. How it is less, we'll see it. So your switch can understand MAC address. So when PCs are communicating each other, for example, PCA send a packet to PCB. The packet is travel through switch. The switch understand PCA MAC address, and the port means, can you see there is a connections are there, no, the sockets are there. So that socket we call it as a port here. These port numbers, okay, so that is MAC address of device and the port number where it is connected, which port it is, the device is connected, that port number. Like a port number 1 is connected to PCA. PCA MAC address is, for example, 1A. Port port number 2 is connected to PCB and PCB MAC address is 1B. Okay, like that, it is trying to map. It is when these PCs are initially switches act like a hub, means initially it is broadcast, but when devices are communicating each other, the switch learn the MAC address of the devices map to the connected port number. So that is called a MAC address table. That is called a MAC address table. So switch use initially a broadcast like a hub, but once it is learn the MAC address of the devices and map it to port number where the device is connected, that port number it mapping like that. That mapping we call it as a MAC address table. Okay. So using this MAC address table, it start using unicast. For example, PCA want to send a packet to PCE, for example. So packet is went to the switch, and a switch will verify what is the destination MAC address. Destination MAC address is 1E. 1E is connected at a 6. So it send a packet to port number 6. So automatically PCA got it. Similarly, for example, PCB want to send a packet to PCD. So packet sent to the switch. The switch check the destination MAC address. It is 1D. 1D is mapped to port number 5. Okay, and then packet is directly sent to the port number 5. Then PCD will get the packet. So this is the use of this here switch. Again, hub and switch both are used for LAN communication, guys. Hub and switch both are used for LAN communication. Okay. Star topology. Hub and switches used for a star topology. Both are used for LAN communication. Hub is non-intelligent device. Switch is an intelligent device. Switch can understand MAC addresses. Switch create a MAC address table by learning of MAC address of the devices and map it to the port, the port number which the device is connected to it. Okay. So switch hub is a layer 1 device, switch is layer 2 device. Switch learns MAC address and forward the packets. And a small note I have written here, that is layer 3 switches. Some people will ask, do you know about a layer 3 switches? Switch is a layer 2 device. So it is a layer 2 device only, not layer 3. But there is a layer 3 switches are there. So the layer 3 switches act like a both switch function as well as a router function. Where we use these layer 3 switches, mainly inter VLAN routing, VTP kind of stuff. So for internet communications kind of stuff, we use a layer 3 switches. Means you need a both requirement, means router kind of stuff as well as a switch kind of stuff also required. Then we use a layer 3 switches. But switch is layer 2. Here it is bridges and switches. Switch is a physical device, hardware device. It contains more number of ports used for a single topology kind of stuff. Okay, like a LAN communication, single segment communication. Bridges are different, guys. Bridges are not a physical devices. So for example, you have a server. On server, you have a 2 NICs. These NICs are connected to different topologies, different segments, different logical or a physical network. They are connected. So you can bridge it. You can bridge it. Okay. Simple example, Wi-Fi hotspot. You connected your internet through 4G, right? You are connected internet through 4G. Using your Wi-Fi, you can share the data to others. You can share the data to others, right? So what is happening with the Wi-Fi hotspot? You receive a internet data from 4G signal, 4G. Okay, you are sharing this data to others through your Wi-Fi. So this Wi-Fi hotspot is another example for a bridging. It is a bridge between your 4G 4G to your Wi-Fi. Both are two different, right? But you are bridging it. That's why you can able to share it. So this is one example. And also repeater. Repeater example is a Wi-Fi extender. You have a Wi-Fi router is there, but you have a very big house. In a certain places, you won't get a more signal strength. What we use, you can use the Wi-Fi extension. So then you can receive a signal much better. It is like a Wi-Fi extension will receive a signal from Wi-Fi router, and again it repeat the signal, so then we can get the signal much better way. It's not like a sucking kind of stuff. It's not like a even a weak signal of Wi-Fi also it will take it and boost it and sending. It is not like that. It's simply a repeater. So we have to put the Wi-Fi extension where the border, the last border where you will find your Wi-Fi signal is better. So then from that one again it is redistribute to your device. Okay. Last one, not a last one exactly say, but this is the one of the important one is router and modem. Router is also a very intelligent device. It understands IP address and other protocols also like a IPX, AppleTalk, SPX kind of stuff. So router understand logical address, routed protocols, routing protocols also understand by your router. Router is inter-networking device. So morning when I told, so I told like a communication between two or more devices is called a inter-networking. So in that one we are using router, right? So same thing here, same point is repeated. Inter-networking device. Router is a inter-networking device. Router is generally used to communicate between two or more networks. Router is used to communication between two or more networks. Router is used in a LAN communication and as well as a WAN communication. Means for internet also we can use it. Router is used for a both LAN and WAN communication. Okay. So router comes in a layer 3 device. Router shows best path to reach the destination. I am here. I am trying to open a google.com. Google.com is located in some different place. Between me and google.com server, there is a several routers. From me to my local router, my internet router, ISP. Okay. My packet is sent to my local router to ISP, ISP having routers, right? So they'll cross the routers and finally we'll reach it. It is like a traveling from one place to another place only, guys. For example, I want to go to Delhi or I want to go to Mumbai. So how to do, or I have to go to railway station. First of all, you have to take some cab or bike or anything, right? Or bus. Think like a bus. So there is a route, right? So several routes are there. Sometimes only one single route, sometimes several routes. One route is very busy. One route is very wide. One route is very narrow. One route is having some problem, then it is a delay. Okay. So different things are there. So routers using certain protocols like a dynamic routing protocols, it will tell you what is the best path to reach the destination. Okay. Sometimes in a Pune, you want to reach faster, you have to take narrow roads. Highway road, main roads are a very heavy traffic. So if you have a bicycle or a scooter kind of stuff, better to choose narrow roads so you'll reach faster. You don't need to stop at any signal also. That is also possible. Okay. no signals kind of stuff is there, or 1 or 2 signals kind of stuff is also there. Okay. So it is depends thing, like broad roads, very big roads are there. You can travel very faster, right? So it is big roads. Okay. No, even the traffic is there. We don't feel much traffic. Like you travel in a highways, you don't feel much traffic. Okay. So it will calculate and it will tell you which is the best path to reach the destination. Okay. So router, again, router is an intelligent device. It works based on logical addressing, mainly IP addresses. Router is an inter-networking device. What is inter-networking device? It connects two or more networks. It makes a communication between two or more networks. Routers can use in both LAN and WAN communications. Router is also used for connecting over the internet. Router is a layer 3 device, which is network layer. The router name came from the root. Root means path. The router means it shows best path to reach the destination. I am showing one command, guys. Just please trace rt google.com. So I have to reach the google.com, right? So, but google.com is not in my home, not in my next home, not in a somewhere in a Hyderabad or somewhere in a Andhra Pradesh or somewhere in the Delhi. It's not there, right? It will be there in some place, right? San Jose, San Francisco, like something it will be there. Okay. So I have to reach that place. I have to reach up to google.com, then only I will get a information, right? So how I'm reaching, what is path I'm going to know that one, this command is useful. Trace RT will shows how you reach the destination, But who will tell how to reach the destination? Who will tell how to reach the destination? Who is providing best path to reach the destination? Is router. The first thing is it is showing IP address of google.com. First it is first of all it should go to my router to ISP router. That is my router IP address. Okay, my router to ISP to some internal ISP routers will be there. Then it should be cross our Indian border, right? And then it will go to another router. Finally it is reach the destination. And we have to reach the destination by 30 hops. Yeah, this is my Airtel broadband router information. Their ISP providers. It is taking time. Of course, no problem, guys. What is the trace RT? Already we have seen ping command, IP config, get MAC, IP config /all. Now this is the trace RT command. What is the use of trace RT command? The router shows best path to reach the destination. Okay, and trace RT command will showing how you reach the destination. The path it will shows from your system to the destination. It shows the path how you reach the destination. Request timed out because of there is some delay happens in between the packet traveling, so it is not getting the information. But the IP addresses it is showing, those IP addresses are a router's IP addresses in between me and the destination. Of course, I think I reached my destination because it is showing 142. So I'm already near to the google.com. Now it is going somewhere. Understand, guys, what is the use of trace RT? We'll reach the destination. Again, what is the use of router? Showing best path to reach the destination. Again, guys, route means path. Router shows best path to reach the destination. So how router knows how to reach the destination. How router knows how to reach the destination. Yes. So it is, we finally reach our destination. I started from my PC. First I go to my router, my ISPs, and then next, like a certain routers in between. Finally I reach the destination. This is the path how I reach to my destination. This is the path how I reach to destination. How to reach my destination by 30 hops means this is 1, 2, 3, 4, 8. So that's I reach my destination by 8 hops. 8 hops means hop means jump. So I have to reach by 30 hops. Otherwise your packet will be travel forever type. Okay. So again, routers. How router knows how to reach the destination using routing tables. Routing tables can be created in the router by manually, that is called a static routing, or it can be created automatically by using routing protocols called a dynamic routing. Okay, these are the dynamic routing protocols: RIP, ASGRP, OSPF, BGP, and ISIS. Interior gateway protocols are RIP, router information protocol, EIGRP, IGRP is also there. IGRP is nowadays we are not using. That's why we are only telling EIGRP. Enhanced interior gateway routing protocol, OSPF, open shortest path first. They have their own algorithms to generate, like I have a 10 routers are there to reach the destination. I have in my network, I have a 10 routers. All these 10 routers using any protocol, RIP or EIGRP or OSPF. Okay. So what is this protocols will do? They build a routing table. Based on the routing table, we know how to reach the destination. We know the how to reach the destination. So it will tell you, these protocols will tell you best path to reach the destination. Enhanced gateway routing protocol, enhanced gateway protocol. In that one, in that category, it is a, sorry, not enhanced, it is interior gateway protocol. Exterior gateway protocol means exterior gateway protocol are a BGP, border gateway protocol, and ISIS, intermediate system. So these are the main one more is there, of course. Few more are there, but first of all, hub, switches, routers, and modem. Okay, this is about a router again. So router is an intelligent device, understand logical addressing, both rooted and routing protocols. Okay, means IP addresses and routing protocols also it will understand. Router is an inter-networking device. So inter-networking means connecting two or more networks, means mainly communication between two or more networks. Communication between two or more networks. It used for both LAN and WAN communication. Router act like a default gateway for a local LAN to outside. When a LAN when you are communicating from your LAN network to outside, router is act like a default gateway. Router is layer 3 device. Route means path. Router shows best path to reach the destination. Router uses routing tables to know how to reach the destination. The routing tables are created manually or by automatically. Automatically means using some routing protocols like a RIP, EIGRP, OSPF, BGP, or ISIS. One more is the last one is modem. Okay. After modem, I will close. So only small point. What is modem, modulator, and demodulator? Guys, in our LAN network, we are using purely digital networks only, digital type of signals. Only 10 Mbps, 100 Mbps type of communication only we are doing. So LAN based communication only we are doing. But when you are communicating from your LAN to outside of the network, means through internet, to connect ISP, to send your request or to communicate through your ISP. So we need a modem. Modem make you connected to your ISP, or we can say modem is connected to internet. Without a modem, we cannot able to connect it to modem. Nowadays, we have Wi-Fi routers or a routers. We are getting a built-in modems. You purchase a Wi-Fi router. Okay, so you purchase a Wi-Fi router. Sometimes Wi-Fi routers are a pure Wi-Fi routers are there, like a Wi-Fi access point wise also there. But Wi-Fi routers, generally what Wi-Fi routers we are using for internet, it contains a built-in modems. If you see a Wi-Fi router, okay, the backside connections are there. So we may need to see this is okay. So can you see this is the blue connection? It is a WAN connectivity. WAN connectivity. The yellow one represent okay. The yellow one represent LAN connection. The blue one represent WAN cable connector. Some routers having a RJ45 means RJ45 connectivity, WAN connectivity. Some are based on internet like a BSNL, Airtel. They use telephone cables. So RJ11 cables also there. So these are a Wi-Fi routers nowadays we are using. So to connect internet. Okay. So it contains like see this RJ11 cable for telephone cable. These are the LAN cables. This is the Wi-Fi modem. So this is go for internet connection. This is the local LAN connection. So you have a internet cable connection means this connection is directly go to connected to the modem part of router. Modem part of router. Okay. So nowadays our Wi-Fi routers are having built-in modems. Again, your router is act like a, a default gateway. Router IP address. So towards our LAN is your default gateway IP address. So whenever you are communicating outside of your network, we are communicating through default gateway. Guys, again, this is also same small office, small office, home office network. Here it is. If you see the modem is try to connect it to ISP. So modem is connected to ISP. Okay, the modem having your username and password. Like you are a subscriber, right? You are having internet means you are a subscriber. So subscriber will get a username and password. So the modem will first of all verify your username and password with a ISP. Okay, your username password is correct, and it will verify your identity. What kind of connectivity you want? You want a 50 Mbps connectivity or 100 Mbps connectivity? What is your subscription? Based on your subscription, ISP check your identity and give the internet to your modem. Modem got now internet. This internet with a different IP address, different network address it is. Okay, it's not our local IP, different network address, different IP address, which is given to the router. Router is inter-networking device. It means it try to make a communication between two or more networks. Means router outside is a different network. Router inside towards LAN is a different network. So this router will do that routing thing here. Okay, sending a packets over the okay, sending a packet from inside to outside, or taking a packet from outside to and sending to inside. So the router is two parts. One is one side our LAN side, another side is a public side. Okay, so another network, two parts of router. And where is this default gateway? Towards our LAN interface. Okay, so that is router interface, that is our default gateway. Now router has a internet. Now how to distribute this internet to your computers? You can connect a router to a switch. Through switch you can give the internet to your PCs. For example, in your organization or in your home, if you have a wireless devices like a laptops, mobile phones, tablets, wireless devices are there. So what we will do, we'll connect a router interface to wireless access point. We connect a router to wireless access point. Okay. So through wireless access point, your wireless devices can able to get connected. See guys, modem is used to connect to the ISP. So then it will send like their identity. This is username, password, and ISP verify your connectivity, authentication, connectivity bill. Okay. So then ISP giving internet connection to your modem. Modem give that connection. Modem is passes to your router. Okay. So the router distribute this internet using NAT and PAT techniques. Okay, so it is route this internet to ours. Okay, by connecting like you have a wired devices, you use a switch, and through switches we can distribute internet to. We can connect through the to your desktops using the switches. In case of you have a wireless devices, you require a wireless access point. So your router or a switch is connected to a wireless access point. Through wireless access point, we can able to get connected. But nowadays, everything is replaced. Simply a single Wi-Fi router having router functionality, switch connectivity, wireless access point, and modem. These are all built in one single Wi-Fi router. These are all built inside one single Wi-Fi router. So that is the point I am trying to say. I hope you understand about a modem, router, and current Wi-Fi router kind of stuff also. This is also same diagram. I explain in different way. Guys, understand up to here? Sleeping, hungry.
Yes, sir. Agree also.
Last point is correct. Okay. That's it for today, guys.